Hi everyone. So we're starting a unit on conics. It's going to be about a 2-week unit, so it's a pretty quick unit. If you haven't already, you're going to actually watch a video. I asked you to watch it before this, but it's okay if you listen to this and then watch it next. It's just a YouTube video. It's like 5 minutes. Okay. So in the video to explain this, but I'll explain it again. A conic is a curve obtained by the intersection of a surface of a cone with a plane. There are 3 types of conics. There's a parabola, which you talked about last year in Math 2, an ellipse, and a hyperbola. We've actually already talked about a special type of ellipse, which is a circle. It just happens to be an ellipse when you have a radius and everywhere around the circle is the same. Okay, so like I said, if you didn't already watch the YouTube video, go back to Google Classroom and click on the the other YouTube video that I attached, okay? It looks like it should start with this, and I'll go through about 5-minute explanation. Okay, so just to build on a little bit of what you guys did last year, I thought we could start off with some some parabolas. So it says draw a sketch of what each parabola looks like. So y equals x squared, we should know, looks like a vertex at the coordinate 0, 0. If we were to just draw a sketch of it, it would be here, and then your parabola would open up. Okay. If we have y equals negative x squared, the vertex is still at 0, 0, but instead of going up, our parabola goes down. Okay. If we have something like this one, our vertex, remember, opposite, so negative 3, 5. We draw a sketch. Negative 3, 5 would be somewhere up here. It's negative, so we know that it has to go downward. Okay, so that's what we're actually going to talk about today. We're just going to, instead of talking about up and down, we're actually going to add on left and right as well. Okay. So the front part of this, the notes are going to be really detailed in definitions. Just make sure you keep really good definitions, so that way if you get stuck on anything on the backside where we actually graph, you can go back to it to kind of make sense of it. Okay. So the distance from the focus to a point on a parabola is equal to the distance from the point on the parabola to the directrix line. What that means is this. So if you look over here, you have a focus point. Okay, if you were to pick any point that lies on this parabola, for instance right here, the distance from this point to that point of the focus is the same as from this point on the parabola to this line that we call a directrix. So this directrix line right here, it's a line. It's perpendicular to your axis of symmetry that goes like this, where your function folds on itself. It's also, this right here is equidistant from here to the vertex as it is from the vertex to the focus. Okay, so those are some things that we'll be talking about. So a parabola is defined as all points being equidistant from the focus and directrix. Okay. Alright, so here's some more definitions. Parts of a parabola include a vertex, a focus, a directrix line, add in the word line, I don't think it's on your notes, and a lattice rectum, which we'll refer to as a focal width. Okay, so I gave you four possibilities. So last year we had a parabola that opened up or down. So this one opens up and has this point right here, which is the focus. Notice it's inside the parabola. And then this right here is your directrix line. Okay. And then, or it could have the directrix line out here, the focus here, because then the parabola is opening down. Okay. Right here is your vertex, or right here is your vertex. So you can see if it opens up, your vertex, your focus is inside but above, or if it opens down, your vertex is here but your focus is inside but below. Okay? Or you could have a parabola that opens left or right. So opening left or right is when we square our y. Last year, remember, we opened up or down because it was always y equals x squared. Okay, so it opens left if we have a negative. It opens right if we have a positive. So left for negative, open right for positive. Just like over here, if we have positive, it opens up. Negative, it opens down. Okay, so this is my focus. It's inside. This is my vertex. And then this line is my directrix. Or I could have it facing right, and then this is my directrix, this is my focus, and then this is my vertex. Okay, so those are your four possibilities. Your standard equation of a parabola looks like one of these two. This one on the left is for x being squared. So because x is being squared, the direction either goes left or right. So left or right. Oops, I'm sorry. Not left or right. So think back to last year. Last year, whenever you had x being squared, it was always up or down. So up or down. And whether it opens up or down is dictated by this right here. If that's positive, then it opens up. If that's negative, then it will open down. Okay, and this is you always can think about this as vertical. So vertical up or down, and the reason is because x is being squared. Okay, if we come over here, this one is horizontal, meaning left or right. Horizontal. And the reason is because y is being squared. So it will either open left or it will open right. It will open left if that 4p is negative, and it will open right if that 4p is positive. Okay? The vertex is the same as what we've been dealing with circles and what you guys dealt with last year. So your vertex is your h and your k value. Notice that there's an h and a k in here, just like there's an h and a k in here. Notice that h is with x, k is with y. The width of your focus, or how long it is what that 4p represents. Okay, and then you need to write this down as well. So p is the distance from the vertex to the focus, or the vertex to the directrix. So meaning if you have a parabola, and this is your focus, so the distance from the focus to the vertex is your p-value, or from the vertex to the line below it is also your p-value. Okay, the focus always has to be inside of your parabola, whereas your directrix is always outside of your parabola. Your focus is a point, your directrix is a line. Okay, so if you need to pause this and write all that down, do so. But to summarize, the p-value is used to locate the directrix and the focus line from the vertex, so that's an important value that we'll have to find. And then the length of the focal chord, notice it's chord, is given by the absolute value of 4p. Okay, so now we're going to go through and we're going to graph and we're going to talk about all these things. Okay, so when you're ready, flip back to the backside. So we have 3 examples for you. And I started you off on one that we should already know because it looks pretty similar to last year. All right, notice that we have an x and that quantity is being squared. So that means it's got to open up or down. Because this is positive, that's what's representing your 4p. Notice in here when we look at the function, notice that x was being squared, and then your 4p was on the other side. And it was the what you would distribute to that set of parentheses. Notice over here, y is being squared, and the 4p is again on the other side, and it's what would be distributed to that set of parentheses or to that quantity. So when we look here, the x is being squared, so we know it's got to go up or down. Because that's a positive 8, it's got to go up. Okay, so we're going to write direction up. And then I'm just going to draw a sketch here so that I get an idea of what this is going to look like. So if my parabola opens up, then that means the focus has to be here, and the directrix line has to be on the outside. So now I know what it looks like. I just have to fit it to the graph that I have. Okay. My vertex, opposite of -2 is 2, and opposite of 3 is -3. Okay, so I'm going to graph that. So I'll go to 2, -3, put a point. Okay, and then from this, I need to figure out, again, look at my sketch. I need to figure out how high to go up for my focus and how far to go down for my directrix. The way that I find that is I say, well, this right here is being represented by 4p, so that means that 4p is 8. So that's supposed to be a 4p that's outside of there. Again, if we look over here, notice that there's a 4p that's supposed to be that's out there. So what we're saying is there's an 8 there, so 4p is being represented by 8. So if I set it equal to 8, I find that my p value is 2. So that's what I need in order to graph this. So if it's 2, that means I'm going to go 2 up, and this is going to be my focus, and I'm going to go 2 down, and then right here is my directrix line. So I'm going to draw a dashed line here. Okay. And then I want to get a little bit better. I am drawing a sketch. It's not going to be perfect, but I do want a couple more points. Okay, so what I can do then is I know that my focal width is 8. So this number right here is 8. That means that the whole focal width, let me show you again. Your focal width is this right here. It goes from your on your parabola through your focus to here. And that total width, that's your focal width, is being represented with that p value. Okay, so because it's 8, then that means that from this focus, I have to go 4 to the right. 1, 2, 3, 4, and put a point. And then 1, 2, 3, 4 to the left and put a point. And then this is just a sketch. So my parabola looks something like this. Okay. And I've seen before people put stars here too, just to kind of show that it's your focus. I don't care as long as the point's there. Okay, now I can go back and identify all these things. So my focus is a point, and it's at 2, -1. Axis of symmetry is the line that goes through my graph where it folds on itself. So just so that you guys can see it, it's this line right here, this vertical line. Okay, and then from there the parabola folds on itself. Notice it's vertical, so because it's vertical I have to write x equals, and it's going through the x value of 2. My directrix is also a line, but it's horizontal, so it's y equals, and it's going through the y value of -5. The focal width was 8, and the endpoints of my focus, one of them is right here at -2, -1, and the other one is at 6, -1. And there you go. So they got to be written out as points or lines or values. Okay, so let's try another one. Notice in this one, my y is being squared, so that means it's got to go left or it's got to go right. But because this is positive, anytime it's positive, it's going to go to the right. So to the right. So that means my parabola is going to look something like this, opening to the right, with my focus being inside there and my directrix line being outside here. Okay, so my vertex, my x value is -3. Notice I didn't pull the value on the left, but I had to go to the x, and it's +1. So I'm going to come plot the point -3, 1. So I'm right here. I know that I'm going to go to the right for my focus. I just need to know how much. So I'm going to set 4 equal to that 4p, because again, that's representing a 4p. So that's telling me that p is 1. So that means from here, I'm going to go 1 here, and that's my focus. And I'm going to go backwards 1, and then this is my vertical line. This is my directrix. So just draw a dashed line in here. Okay, and then from that focus, I need my focal length. And my focal length is 4. So that means I have to go 2 and 2 to make 4. So I go 2 up and 2 down, and then I can connect this. And this is my parabola. And there we go. All right, so my focus is at the coordinate -2, 1. -2, 1. My axis of symmetry is different this time because my axis of symmetry, I'm going to draw this in here again so you guys can see. My axis of symmetry is going here. So since it's going there, it's a horizontal line, which means it's y equals, and it's going through the y value of 1. My directrix, these are always perpendicular to each other. So if that one's y, then this one has to be x equals. And it's going through the x value of -3. Oh, I'm sorry, not -3. Let me take that out. It's going through the x value of -4. It's the dashed line. Okay. My focal width is 4. So it's the total length from one focal point to the other. And those endpoints were at -2, 3. The order does not matter. So -2, 3, and -2, -1. Okay, notice from 3 to -1 is your focal width. Alright, so that was right. Now we're going to try, since we've done a lot last year with up and down, we're going to try some more with left and right. Okay, so this one, notice again it's y that's being squared, so that means it's got to go left or it's got to go right. But because of this being negative, that's what's going to make it go left. And again, I would draw a sketch so that way when you plot your points, you know what direction to go with your vertex. So if it's going left, that means it's opening to the left, which puts your focus in here and your directrix line out here. Okay, so again, it helps so that I can say here's my vertex, and from there I go to the left and I go to the right. My vertex, the opposite of -4 is 4, and then with the y there's nothing there, so then that means it's at 0. So I'm going to go 4, 0 and plot a point. Okay, now I need to figure out how much to go left and right. Notice I go left and right because it's y being squared. So I'm going to say -12 equals 4p, which means p equals -3. The fact that it's negative is only because I'm going to the left, but so from here I'm going to go 1, 2, 3 to the left, and there's my focus, and 1, 2, 3 to the right, and now from there I need to draw my dash line. So this is my directrix. Make it go all the way top to bottom. Okay. From my focus, I need to figure out what my focal width is, and that's what this -12 is. So, again, the negative doesn't matter. So that means I have to go up 6 and down 6. So up 6 puts me here, and down 6 puts me here. And again, this is just a sketch. It's not perfect when there's only 3 points. So I go here and I go here, and then that's my parabola. So because of that, and the graph is what's helping us get a visual, but the other half of this is being able to identify all these points too. So my focus is at the coordinate 1, 0. My axis of symmetry, notice that it has to go horizontal. So it's going through this right here. So because it's going horizontal, it's going through the y value of 0. So y equals 0. So it's a hard one to identify. The directrix, if that's y equals, then must be x equals. They're always opposites since they're perpendicular. So the directrix is x equals, and it's at x equals 7. Okay. My focal width was 12. Don't put -12. Distance or length can't be negative. And the endpoints of my focus are at 1, 6 and 1, -6. Okay? And you guys will do that a couple times in your homework. But same idea every single time. It's just a matter of what direction it opens. Okay? I actually want to talk about some of your homework. So before you move on, I just want to show you a couple things. So again, in here, the number 1 looks similar, number 2, number 3, they all look similar to your notes that you can go back to. But I want to talk about number 5. Notice in number 5, you have everything on one side equal to 0. You're going to have to move this over to the other side by subtracting the whole thing. Oops, -3. And then do that to both sides. So that way what you'll end up with is your x plus 2 squared equals -2 times y minus 3. And now it looks exactly like your standard form. Since x is being squared, it's got to go up or down. Because that's negative, it's got to go down. Okay, so always relate it back to what you did last year. Last year, it was always x squared, so that's why it was up or down. So that way, then, if it's not x squared, you know it's got to go left or right. Right if this number is positive, left if it's negative. This one goes, though, down, since it's x squared with a negative. Okay? And then I want to talk about one of these problems as well. So you'll do a couple, problems. You'll have 3 problems here where you're going to have to write the equation based off of what you see. So I thought I'd help you with one of them. The fact that this opens to the right and not up or down means it's got to be y that's being squared. Whatever is being squared, we write first. So if this point right here is my focus, then that means this is my vertex, and then this is my directrix. Okay. Notice that if this is at x equals -1, and this x value is 3, that the vertex has to be directly between that. So if you think about a number line, if you're at -1 and you're going to 3, that's a total distance of 4. So that means from this point to this point, you got to go 2, and you got to go 2 more to get to here. So if you're at -1 and you go right 2, now you're going to be at the coordinate 1. And you have to be at the same y value as what this y value is, since they're all in line. So that's my vertex. Okay, I know that I know it's got to be y that's being squared since it's going to the right. So I'm going to say y, and then I notice I have to look at my y value. So I just need to say y minus 8 squared equals, I need to put something here for my 4p value, and then this is going to be x minus 1. Okay, so again, I know that my 4p equals, and I'm trying to figure out what that 4p value is. Okay. I don't know what this value is to set this equal to anything because I'm not solving for p. But I can figure out what p is because remember I solved this so that I can figure out that p is the number that makes me go from my vertex to my focus and my vertex to my directrix. So I know that it's a length of 2, so that means that p is 2. So I can do 4 times 2, which means that that's 8. So this has to be an 8 that goes here. Okay, and I can double check it. All that means is I would say 4p equals 8, which means p equals 2, which is correct because from here to here was 2, and from here to here was 2 as well. Okay, and then I'll let you try number 9 and 11. The answers are down below here as you guys work through and answer all these. The important thing to notice is whether things are points, whether things are lines, or whether they're values. When you're graphing, pay attention to are they left, are they right, is it up, is it down, what makes it go left, right, up, down. Okay? All right, and then tomorrow we'll talk again about parabolas, so we'll have 2 days on this. Okay? All right, thank you. Have a good day, everyone.